support vector missions. Support vector missions means, sorry, SVM. SVM is the meaning of SVM is support. S stands for support, vector, V stands for vector, and M stands for missions. Support vector missions, right? So this is the first algorithm. It is one of the type of algorithm in classification, which is called as support vector missions. Now here it is going to work on the based on the support vectors. Okay, based on the support vectors. And now what is support vectors, we are going to understand in detail one by one, right? Now suppose we are having a data points like this. We want to separate the data. Okay, and for example, if you want to predict any new point, this is the new point, and you want to predict whether it belongs to green class or red class, means in the previous class what we have done is KNN, we identified the nearest neighbors. Now in this class what we are going to do is, first we'll separate the given data. Whatever the training data they have given to us, we'll separate them. For example, we are going to draw a straight line like this and we'll separate the data, or we'll draw a straight line like this and we'll separate the data. We'll draw a line like this and we'll separate the data. By using one line, we are going to separate the data. Once the data was separated, now if you want to predict any new data point, if this is the data point is there, this data point belongs to green class or red class. If it is available red, means it is called as red class. For example, you have separated the same example, you have separated a line like this. Now it belongs to red class. The same thing you have separated like this. Now it belongs to green class. Now here we are having, with respect to the concept behind this one is, first we have to separate the given data. The concept behind this. So whatever the data points they have given to us, training data set. It is not going to work on the test data set. Only the trained data set, whatever the trained data set they have provided, inside that the categories, whatever the categories are there, the categories will be separated by using a linear line. By drawing one linear line, we are going to separate the data points. The linear line can be this one, the linear line can be this one, the linear line can be this one, or linear line can be this one. Now out of these many lines, which line is the best fit line? Which is the best one means, we are going to identify which gives the maximum margin. The difference, the line which has the maximum margin between the classes, that is called as, that line we are going to select. Whichever the line has the maximum margin, that particular line we are going to select. So this is also called as maximum margin classifier. Okay, the support vector classifier is also called as maximum margin classifiers, because it works on the, it is going to select a line such a way that it is going to select which gives the maximum margin. So it is going to try first this one. This is one of the line. It will check what is the margin for this. It will try with this. It will check the margin, whatever the margin is available. Like that, it is going to check for all the lines, and which line is having the maximum margin, that particular line will be selected. And once the line is selected, we are going to separate the data. Now, why sir, why maximum margin you have to select? If you select with respect to a line like this, let us assume you have selected a line like this. Instead of a maximum margin means which is equal distance between both of them. Instead of that, you have selected a line like this. Now what happens means, since this side one side we are having the red distance is low and green distance is very high, this is called as biased model. So there is a high bias. One side bias is there, means one side we are giving the high value, means it is considered as a bias. So when there is a bias, automatically we are having the overfitting or underfitting. First they have tried with it like this only. First they have taken a normal line like this, which was easily separable. Now they have checked. After checking that one, they have observed there is a underfitting problem. Why there is an underfitting problem? This one miss. The reason behind this is, one side you have given more things. So when you are one-sided, automatically it is called as bias, right? So now whatever the bias is there, so to eliminate that bias, they have came with a solution that we have to select a line which gives the maximum margin on the both the sides. It should be a center line which passes and which gives the maximum margin that differs, that separates the data, right? Sir, in this case, the example is very simple and you are classifying, but assume that there is a data set where one of the data point is here the green data point also available. One data point of green is available here. One red point is available here. Now how it is going to do? It is not going to do 100% classification. It is not going to apply a line like this. Where it applies a line like this means easy 100% classification can be done. But it will not do like that, because it is going to have the overfitting problem. If it does in that way, it is having the overfitting problem. So it is going to make it generalize only. One or two values are misclassified also, no problem. We require with respect to generalize, not with respect to overfitting. So that is the reason we are going to select a linear line. So for example, if I go with a non-linear line means like this. I can select a non-linear line also. What happens if I go with a non-linear line? Okay. What happens if I go with a non-linear line means sometimes it leads to the overfitting problem, right? So just, sir, whether I have to select a linear line or non-linear line, how I can decide? So that we are going to decide based on the hyperparameter tuning. In the hyperparameter tuning, we are going to give this one of the parameter, whatever the parameter is there, that parameter grid, the grid values, we are going to give linear and non-linear. Both of them will give. Automatically, it will not apply. Whatever the options are there, which one is best? Instead of asking that question, try all of them. How to try all of them is by applying the grid set CV. In the grid set CV, automatically it will only apply, right? You are not going to apply manually. It is going to apply automatically by using the for loop. So whatever the options are there, everything we are going to give to the hyperparameter tuning. And within that, what is the best one? It is going to identify, right? So there is no, in the machine learning, in entire machine learning, there is no word which is the best one is available. The problem in machine learning is we have to try multiple options. Okay, there is no fixed code. Fixed pattern is not available. That is the problem in the machine learning. There is no fixed pattern, or for this data set, we have to do in this way only. For example, since it is a simple data, it is easy to classify this one and we'll get 100% accurate results. But if you are having some of the data points here, green data points are there. Some of the data points, green data points are here, and some of the red data points are here. In this case, we'll get a less accuracy. We are not trying for getting 100% accuracy. We are not working for getting 100% accuracy. We are trying to get a generalized model for most of the problems and most of the scenarios. It has to give the best result. For example, if you are opening a companies in the job portal, you are opening the whatever the jobs are available. You have went to a particular job portal. In that particular job portal, one of the job portal, they have given with respect to, sir, the requirement we required is the person data science. Along with that, one should be good at website design also. They have given like this. Assume. Are we going to learn the website? Based on one company, we are going to learn that one. Basically, website design is full stack developer role or website design or front-end developer role. But still they're asking us because, for example, let us assume there is a person. The person name is called as SRK. And he wants to start a company. Okay, tomorrow morning he has started a company. And he has got a project. The project is worth of 5 lakhs. Now, in this 5 lakhs project, there is a requirement with respect to cloud is there. Okay, one person should integrate the cloud or something. And that too, the cloud is AWS. And data science work is there. And data engineer work also is there. This is a 5 lakhs project. And these are the 3 works they have given inside that project only. Everything was there. Now, I have to hire one person. I can't do myself. I have to hire one more person. Now, if I require with one more person, now what I'm going to project means I'm going to have with respect in the job portal, one should be good at data science along with the cloud, along with the data engineer. I'll ask like this the requirement. Because my money is with respect to low cost. I'm not having that much of money to give the separate people. For cloud and for DS and for data engineers separately, I'm not having the money. So at that time, I'm going to ask everything in one person only. Right? Similarly, one more job, if you go to one more job, they'll ask with respect to something. One should be good at data science along with that something. One should ask with respect to data science with respect to NoSQL. One will ask with respect to data science with SQL. Some person will ask with the data science with something else. Now, which one you are going to prepare? If you see like this, how many you will observe? Miss, number of things you will observe. That is as per their company requirements, they are posting their jobs. Generally, what is data science is common thing is there, right? So here, what we are going to learn is generalized thing. We are not dedicating our requirement to one company. If it is a corporate training and you are the corporate employees of Infosys and I'm giving the training in Infosys means as per the requirement of Infosys, I will train you according to that. Now here it is not with respect to one side. So we are going to have the generalized model. We are not going to select any particular thing. So the same example will be applicable here also. So here we don't require the train accuracy of 100%. And at the same time, for one data set, one thing is applicable means for another data set, another thing will be applicable. In one data set, SVM is best one means in another data set, random forest will be best. In another data set, XGBoost will be best. In another data set, logistic regression itself will be best. So data set to data set, the solution also changes, the algorithm changes. And yesterday's example, whatever the example we have done for the cancer patient data set, that is K value is equal to 20 is the best one. Hyperparameter tuning we have applied and K we have got as 20. And if you have applied the same logic for the diabetic data set, you will get the K value as a different answer, not 20, right? For data set to data set, the K value is getting differed. The accuracy is getting differed. There is no fixed rule we are having. Similarly, here also, there is no fixed rule in the entire machine learning. So here we are going to try with the linear and both non-linear. So when you are going to apply the linear classifier means just by applying a linear line. Linear classifier means with respect to by using a linear line and separating the data. This line should be selected, which gives the maximum margin, which classifies with maximum margin, right? So these are called as support vectors from which the class has converted. Up to that, all the data points belongs to one category. From here, it is going to convert to the next class. This class from where the changes happens, that one is called as support vectors. These are called as support vectors. And left side is called as one class and right side is called as another class. For example, here, whatever the line you are observing, since it is a two-dimensional, whatever you are observing, it is a two-dimensional, this is called as a line. For example, this is a three-dimensional. Let us assume a three-dimensional, means in this class, a three-dimensional. Now, if I open this pen like this, now this pen, whatever you are seeing, the pen is a three-dimensional object. It is not a two-dimensional object. Unless you project this one on the board of this one, on this wall, which is a two-dimensional, then only you can observe this one as a straight line. Otherwise, basically, it is a three-dimensional body. Similarly, here, when you are working on the higher dimension, that is called as hyperplane. They are called as hyperplanes. Okay, the hyperplane means not something like this. You are having the like this. Beside to this, with respect to one type of data points, beside to this one type of data points. A three-dimensional body. When you are working on the more than two dimensions, this line is called as a hyperplane. When you are working on a two-dimensional, this is called as a simple line, just as a line, right? So this is called as hyperplane and this is called as maximum margin classifier. Support vector classifier is also called as maximum margin classifier, right? Now, what is meant by these support vectors? Support vectors means from which it is going to convert the category. Example, let us take with respect to some examples. We are having with respect to apples and oranges. Apples or green apples are available, red apples are available, light color orange apples also will be available in the market. Pure red color will be available, light orange also will be available. A similar kind of oranges also, pure orange will be available or light color orange also will be available. Now, what is the special about SVM means here the support vectors, whatever we are having, these are the complete oranges and apples means these are normal things. Whatever you are observing, these are normal things. Whereas this one, this is an apple or orange. It is with respect, but the color is orange color and shape is also almost close to the orange, but basically it is an apple. So this is considered as an support vector. From this, everything is considered as an apples. This is the support vector for the apple. This is the support vector for the apple, right? So Similarly for oranges also, within the oranges also, all the colors cannot be with respect to orange. Some of the colors with respect to like this, some different colors also will be available, right? So this is the support vector. Is that clear? Now, sir, there is a data like this. There is a scatter plot and there is a data. Now, if you apply a linear classifier on this, let us apply a linear classifier, a line like this. It not classify 100%. If you apply a line like this, no. If you apply a line like this, no. If you apply at least like this, one side is full of red is there, but other side, red and green also available. Then how? In this case, how we are going to do? What we are going to do is, see, because the data points are not linearly separable, we are going to have on the non-linear separation. Now, non-linear separation is one option, or second option is move on to the high dimensional space. The special of SPM is high dimensional space. Now, how we are going to move on to the high dimensional space? Let us observe this one very clearly. Okay, I'm having some of the data points like this. The points are 1, 2, 3. And this one is with respect to 6, 7, 8, 11, 13, and something values like this. We are having some values like this. Now, these are the data points where it is a one linear. If I want to draw a line, if I draw a line like this, it is not getting separated. Now, what I'm going to do, just focus on this now. Please clearly focus on this. What I'm going to do is first, I'm going to do the, wherever the first support vector for the green is there, the value, whatever the value 6 is there. So what I'm going to do is first, I'm going to take x minus 5. X minus 5 means 1 minus 5. What is 1 minus 5? Minus 4. 2 minus 5, minus 3. 3 minus 5, minus 2. Each data point, I'm going to separate minus 5, minus 5, minus 5. Now, the points will be shifted like this. Where this is the first one is minus 4, minus 3, minus 2, plus 1, plus 2, plus 3, and some kind of 6, 7, 8. Some values you'll get like this. Now, each value you have separated with minus 5, each of them. Now, what I'm going to do, I'm going to make x minus 5 whole square. I'm going to do the square. Square means nothing but minus 4 whole square, 16, minus 3 whole square, 9, minus 2 whole square, 4, 1 square, 1, 2 square, 2, 4, 3 square, 9, 36, 49, and 64. I'm going to take the values, square of the values. Once I square of the values, now whatever the values are there, these values, here for example, 1 square, 1, 2 square, 4, and 3 square, 9. Whether these colors are what colors? Green colors. Because green data points you are squaring means automatically that one also will be the green colors. Red colors, whatever you are doing the square, that will be the red colors. So I'm having the green colors and red colors, right? Now, simply I'm going to use a line like this and I'm separating. Okay, is that clear? Earlier the points are like this, where you can't separate the data, but just you have increased the dimension. Now you are separating this one. Earlier it is a one dimensional. Now it is a two dimensional, because whatever you are having this point, in order to make this point 1, 1, 2, 4. 2, 4 means y you have selected. Actually you are having only one dimensional basically. 1, 2, 3 and 6, 7, 8, whatever the values are there, you are having basically one dimension. You have created one more dimension by using y is equal to x minus 5 whole square. And this x minus 5 whole square, that is 1 minus 5 whole square, which is 16. 2 minus 3, 2 minus 5, that is minus 3. Minus 3 whole square is 9. 3 minus 5 whole square, that is 2 square, 4. 6 minus 5 whole square, 1. 7 minus 5 whole square, 4. 8 minus 5 whole square, 9. Now just you are using these values and this value. 1, 16, 2, 9, 3, 4, 1, 5, 4, 7, 8, 9. You have projected the points. Now you are having two columns, scatter plot. You have made a scatter plot between these two values. Basically, the data is only one dimensional data. You created one more column. You created one more column, and by creating one more column, by increasing to the higher dimension, and you are going to separate the data points. So the same thing is done. Is that clear? So when it is not linearly separable, we are going to increase to the higher dimensions. Sir, you have increased to x minus pi whole square. Okay, it is separating. Assume that in x minus pi whole square also it is not getting separated. Then whole cube. I will try with the higher dimensions. I will increase the dimensions. Number of dimensions I will increase. Based on whenever there is a easily separable is there, at the time I'm going to separate the data points. Now, when I have increased the higher dimensions, see the points are separated like this. Now, when the points are separated, just I'm going to apply the hyperplane. By increasing the higher dimensions, just I applied the hyperplane. Basically, it is a two-dimension, x1 and x2. There is no x3 is available, basically. I created a third dimension, x1 and x2, as it is x1 and x2, along with the third dimension. I created the third dimension. And when I have applied the third dimension, the data was separated like this. And here I have applied a hyperplane and I have separated the data. Right? By increasing to the higher dimensions and separating the data is called as support vector meshes. That is support vector meshes. Basically, whatever you have seen earlier, that is called as support vector classifier. This is called as support vector meshes. Meshes means which increases to the higher dimensions. The mesh will increase to the higher dimension and it is going to separate the data. And this hyperplane, if you project, it is a circle. Basically, it is circle only. But how you have got that circle means that is the backend. Is that clear? So just what you have done is here the one-dimensional space, whatever the one dimension is there, you have increased the to the higher dimension. Once again. So here, whatever the example is there, I have observed this one. This is a one-dimensional. One-dimensional means I have to use a single line. By using a single line only, I have to separate that one. But I'm using any line, it is not getting separated. By using a single line, I'm not able to separate that one. Now, what I'm going to do is, whatever the value here, some value will be there, right? Assume the value is 6. Assume the value is 6. Now, I'm going to do x minus 5. Assume the value is 14. This is 7, 8, 9. This is 14. Then x minus 13 I am going to do. From where this part will be separated. The distance between these two will be there, right? This data point and this data point. What is 10? This is 7, 8, 9, 14, 15, 16, 19, 20, 21. Something you are having like this. Now 5 and 9 and 14 is there. 9 and 14 divide by 2. 9 minus 14 divide by 2. What is that? 5 by 2, which is nothing but 2.5. So just I'm going to apply at 11.5. I'm going to separate the data. X minus 11.5. I'm going to write here x minus 11.5. When I have written 11.5, automatically these values will come automatically left to the 0. 100% it has to come to the left side of the 0 because all of them are less than 11.5 only. So why 11.5 only? Because equal margin should be there, right? For both the classes, equal margin should be there. If I go with the 10, 10 also will be separated. But what happens with respect to bias? On one side, I have taken the bias. So I'm going to select with respect to 11.5 as the value and I'm going to select. And I'll separate the data. Once the data points are separated, now like this, the data points are separated. Whatever the minus is there, after doing the minus, the sum of the data points has came to left side of the 0. Now I'm going to project them. After projecting them, simply I'm going to make a line. Is that clear? Is that clear now? So here the x minus 5 is an example only, not always x minus 5. In my, if you are assuming this value is as a 4 and this value as a 6, then center value is 5. By using the 5, I am separating. For this example only, 5 is applicable. For example, here 9 and 11 are there, means value will be 10. The center value. Right? So can't we do without x minus 5? Yes. Tell me, is there any other option to do with x minus 5? Apart from x minus 5? You are having a data points like this. Let us take a data set like this, where x and y values are there. First one is 1, 2, 3, or with respect to 4. and 6, 7, 8, 9, 10, 11. They have given like this, out of which output variable is yes, 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 no, 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 yes, yes, yes. This is the data set. This is the data set. For this data set, just apply the scatter plot. Just apply the scatter plot. That too, without using the y variable like zeros or ones. If you apply zeros or ones means you'll get s values downside, y values on the no values on the other side, and you will apply the logistic regression. That is one type. In that model, it is going to work on that way. So for example, you have taken here 1, 2, 3, whatever the 1, 2, 4, and these 3 green points you are going to write here. And red points again, you are continuing like this. Now in this case, what happens? You are going to apply the logistic regression. So I'm not applying the logistic regression. This is one more type, how to classify the data. That is one type. This is another type. That is one algorithm, and this is a different algorithm. Right? Now for this data set, now I'm applying the whatever the, this is the output variable. Don't write y, output variable. Now for this data set, first you plot the values. That is 1, 2, 4, 6, 7, 8, 9, 10, 11. Q is equal to output. Okay, in the SNS.cburn, Q is equal to output. So 2 colors you are going to get. One is green color, one is red color. Now this is the plot. For this data set, this is the plot. Now you tell me how we can separate the data. By using a single line, you can't use the 2 lines. 2 lines, that too, a single line you have to use. That too, it should be a straight line, linear line. It should not be a curve. It should not have any polynomial curve. Sir, I can separate like this now. This is also a single line only, right? Single line. This is also a single line. I can separate. This is non-linear, right? This is non-linear. We are going to discuss. Once the linear is completed, I will show you the non-linear also. If I want to separate this one to linear, by using a linear line only, I want to separate. What is the other option? What is the option I am having? The scientist has think in that way. If I want to separate linearly, what I have to do? Why we can't increase to the higher dimensions and we can't separate them? He has got an idea like that and he has created the algorithm. One more scientist has got a, hey, why do all these things? Simply draw a line like this, complete. One more scientist has came with a solution that you can take like this, which is called as non-linear SVMs. One is linear SVM, one is non-linear SVM. Okay, if you are able to separate the data points by using a linear line, it is called as linear SVM. If you are able to separate the data points by using only the non-linear line, it is called as non-linear SVMs. Right? So they came with a solution with non-linear linear SVMs directly by. So mapping to a higher dimension can be with respect to computationally very high. In real life, SVMs are very less used. Okay. If you are having a large amount of data set, SVMs will take so much of time. And it requires very high computational power also. Computational power means in terms of RAM or processor speed. It should be very high, right? Because it has to increase to the higher dimensions, right? So number of dimensions will be increased. Means, for example, you are having x1, x2, x3, 3 futures are there. Means it is going to create one more future also. Do you remember the polynomial regression? In the polynomial regression, you have taken the for 3 input variables, TV, radio, and newspaper. If you apply the square only, you have got 9 quotients. If you have applied up to 20 means, degree of 20 means how many quotients you will get? You know? And that too for 3 variables only you are having like that means, assume they have given the input data of 50 variables are given. For 50 variables, you have done the degree of 20 means, then literally the system will die. Right? So it is computationally very high. These models are computationally very high. Now they came with a solution. Okay, computationally it is taking very high. If you are increasing to the higher dimension, now what is then what we can do? They came with a solution called as kernel SVM. Okay, the next one is called as kernel SVM. Earlier one is linear SVM. Now we are moving to the non-linear SVM. Non-linear SVMs are also called as kernel SVMs. Right? So then next one is kernel SVM. So kernel SVM is non-linear SVM. Within that, what they have created is non-linear lines, out of which the first one is we are having different types of kernel functions are available. Out of which the first one is Gaussian RBF. RBF kernel is the first one, where it is going to separate the data points based on the normal distribution line. Normal distribution is also called as Gaussian distribution. Both are same. Normal distribution, symmetrical distribution, Gaussian distribution, everything are same. Right? First one is RBF kernel. Second one is sigmoid kernel. By applying a sigmoid line, one curve is our normal line, normal curve line, that is bell curve. By using the bell curve, you are going to separate. Second one is by using the sigmoid line, you are going to separate the data. And the third one is polynomial. There is no particular shape is available. You can separate like this also. There is no particular shape is available. Then it is called as polynomial kernel. Okay, three different kernels we are having. One is RBF kernel, which is going to use the bell curve. Sigmoid kernel, which is going to use S curve. And polynomial kernel, which uses with respect to the degree. Whatever the degree you are writing, that degree it is going to use. Now, so for my data set, which one I have to apply? We don't know. So what we are going to do is, we are going to apply the grid set CV and we are going to write kernel is equal to, in the grid set CV, in the param grid, we'll give the linear, we'll give RBF, we'll give sigmoid, we'll also give the polynomial. So automatically it will only apply all of them. It will tell the best one, which is the best suited for the given data. Now, assume that this is the data set. Assume a data set is like this. This is the data set, where you can separate this one by using a linear line. Option number 1. The same thing you can separate by using the RBF kernel like this. This one also you can apply. Second one, you can go with the sigmoid kernel. You can apply the sigmoid kernel and you can separate the data. And you can apply the polynomial kernel, that is quadratic equation, by using the quadratic curve. This one also you can separate the data. Now you are having these many options are there, where everything has given the 100% accuracy. Linear has given 100% accuracy. Kernels also has given the 100% accuracy. Now all of them are giving the 100% accuracy. For this, which is the best one? If everyone are giving the 100% accuracy, same accuracy, then out of which is the best one means which has done in the less time. Basically, the linear one will be less time. So the top priority will go with the linear one, which has the less time. Right? So when the accuracies are same, the next priority goes with respect to the time. First priority is accuracy. If accuracies are same, if the word of if is there, if accuracy are same, for example, logistic regression, KNN, SVM, three of them you have applied on the same data set. Logistic regression has given the test accuracy of 92%. KNN also 92%. SVM also 92%. Everyone are doing the same. For example, this has given 93 means blindly we have to select SVM only. There is no other option. We have to go with SVM. If everyone are same, then which one gives the less time, that we have to select. Out of these three, which is giving in the less time, we have to calculate that less time. How to calculate the time is, there is a function called as percentage time it, which we are going to discuss in the further. Don't worry. Okay. By using that one, we are going to identify which algorithms gives with respect to less time. For each algorithm, whatever the time it has taken, we are going to identify. Once we identify that one, then we are going, based on that, we are going to identify which is the best one. Is that clear? So by using the different types of kernels, we are going to separate the data. Now, here, what are the important hyperparameters in SPM? Important hyperparameters of KNN is n neighbors, and the second one is p value. The p, whatever the Euclidean distance or Manhattan distance you are selecting. For SPMs, what are the hyperparameters? Means one of the hyperparameter is kernel. Which type of kernel you are going to use? That is one of the hyperparameter. The second hyperparameter is C value. There is C. C means nothing but it is a regularization parameter where it is regularized, which is inversely proportional. The strength of the regularization is inversely proportional to C. For example, you have given the higher value of C means you are trying with respect to the less amount of data points as the support vectors. The lower the C value, you are giving more amount of data as the support vectors. If you want support vectors more means, then we have to go with the less C value. Support vectors of less means with respect to higher the C value. Right? So if you give more number of support vectors, there is a high probability it leads to the overfitting problem. At the same time, if you give with respect to less value, the support vectors are very less also, it will lead to the underfitting problem. So we have to do the optimization. Optimization is nothing but we have to identify best C value. Optimization is nothing but again hyperparameter tuning only. Hyperparameter tuning is called as optimization technique. You are optimizing and you are identifying the best parameters which gives the best value. Basically, it is called as optimization technique. Right? Is that clear, guys? Now, so here I'm going to work on the one of the problem. So recently everyone knows with respect to COVID, right? COVID data set, and now recently we are going to get the one more variant with respect to BF7, right? A new variant has started from 2 days, right? In India also it has spread it, and most probably within 1 or 2 months, again maximum not even 2 months also, maximum of 2 weeks, everyone will start again mask, right? Now the thing is that whatever the this kind of variants or whatever the COVID is there, so for COVID we have to have a medicine. We have to get into a medicine. We have to identify the which is the best medicine for which fights against the COVID, right? Now what they have done is this COVID, whatever the virus is, the COVID virus, they have injected this one to the mice. Mice means nothing but rat. So they have given to the mice, and they have checked with, they have given the different medicines to the mice. They have injected different combinations of medicine to the mice. And after that, they identified whether it is killing the virus or not killing the virus. The same project was done in the Dr. Reddy's. Okay. Not exactly the same data. I can't take the exactly the same data. If I take the exact same data means it is called as copyright issue. We can't bring the exact data from the companies, right? So here, what is the goal is to create a classification problem that can predict based on the given dosages whether the mouse, whatever the mouse will be still infected with the virus or not. Whether it is infected. So they are going to try on the rats, rabbits, all these things, right? Initially. And once they are successful, they'll try on the humans. And once the humans are also successful, they are going to apply the hypothesis test. After the hypothesis test, they are going to submit whatever the report is there to the DG. That is Director Control of Drug Controller. DG? Whatever it is. Drug Control of India. Simple DCI. Drug Control of India is there, right? So for them, they are going to submit the report. Whatever the report they are having, they are going to submit after hypothesis testing. So in the hypothesis test, they'll identify with respect to the true positives and null hypothesis. They'll formulate the null hypothesis that it will not affect, there is no change. This medicine has no impact on the COVID. No impact on COVID is the null hypothesis. Impact on the COVID. This medicine reduces the COVID. Is the alternate hypothesis, which they have invented. This is the research hypothesis. So they are going to prove this one, p value greater than 0.05, p is less than 0.05, p low, null go. They'll reject the null hypothesis, and this particular medicine will be released into the market. right? So this process, whatever the process is there, before applying that process, first, before moving on to that one, so they want to check by applying the machine learning algorithms, right? So here, what I'm going to do is I'm going to import the libraries, that is NumPy, Pandas, Matplotlib, and Seaborn. And here I'm having with respect to a data set where medicine 1 and medicine 2, both the medicines are there, different proportions are there. Now, if I give a proportion of 1.6 and 2.5, whether the virus will die or virus will present. This generally how we have to check this one, by doing the experiment. Generally, we have to do the experiment. To predict this answer, generally what they have to do is they have to create this, they have to take 1.6 ml of the medicine 1, 2.5 ml of the medicine 2. And both the things they have to inject onto the mouse. So they have to inject this one to the mouse. And after that, they have to check whether the virus is killed or not. They have to check. Generally, they have to do this one based on the experiment. But without doing the experiment also, we can predict the answer. Without doing the experiment also, we can predict. That is by using the machine learning. So here I'm having with respect to the info, total 400 records are there. And the output variable consists of zeros and ones. One is virus present and one is virus not present. Now, if you apply the scatter plot, that is X and Y, and if you take the virus, that is hue is equal to virus present, the output variable, which is discrete variable, you are going to get a scatter plot like this. Now, in this scatter plot, now we can separate the data like this. Now, for example, the 1.6 and 2.4, 1.6 and 2.4, where is 1.6? This is 1.6 and 2.4 means this is the point. Assume this is the point. Now, this point tells whether it is a 0 or 1. Simple. Once we make here in this example, just what we are going to do is first we are going to identify the relation. And based on the relation, we are going to predict. For example, you want to predict whether 1.8 and 2.7, what is the output? 1.8 and 2.7 values are not there in the given data set. We have to predict the answer. So what I'm going to do is I'm going to take X is equal to medicine 1 and medicine 2 and the output variable virus present, whether the virus is present or not. And train and test data, I'm going to consider of 0.2 train data, test data. And first I'm going to take the support vector mission with default parameters. So I'm not going to change the default values. So what is the default parameters? Means the default parameters of C is equal to 1.0 and kernel is by default RBF kernel. By default, it is applying the RBF kernel with C is equal to 1.0. That is the default values. Okay, and I have got the train accuracy and test accuracy almost 1. Right? Now, what I'm going to do is I'm going to apply the hyperparameter tuning. So within the hyperparameter tuning, now here in this code from sklearn.spm import SPC. Yesterday from sklearn.nibus we have imported the K nibus classifier. Here we are importing this one. After that we are saving fit on xtrain ytrain, model.predict on xtrain, model.predict on xtest, calculate the accuracy, train accuracy, test accuracy. Same to same, right? What is the difference between yesterday's code and today's code? Only the thing is import. Remaining everything is same. Only this line will change in the coding. The algorithm will change and according to that algorithm, you are going to fit on the data. In the coding, there is no difference. If it is a logistic regression, tell me what is the code for logistic regression? From sklearn.linear model, import the logistic regression. And you are going to save it as model is equal to logistic regression and model.fit on xtrain ytrain. You are going to predict on xtrain, you will predict on xtest, you will write accuracy score, you will check with respect to original values versus predicted values, train original values, train predicted values, test original values, test predicted values, and you are going to calculate the train accuracy, test accuracy. Is there any coding difference? Is there? Nothing. If it is a KNN from sklearn.nibus, we have to import the K nibus classifier. And we have to save it in the model and fit on the xtrain ytrain, predict on the xtrain, predict on the xtest. Accuracy. Same to same. No difference. Okay. But how it is working when you are fitting on the data, what is this one? This is the most important part. When you are fitting the data, how it is working in the backend. That is the theory part which we are discussing. For this line only, the theory part we are discussing. Remaining nothing we are discussing. For what happens when you fit on X train, Y train, what happens in the backend. That is the theory part of the algorithm. Right? Now, here in the hyperparameter tuning, for this model, the estimator is equal to SVC. For KNN neighbors, it is K neighbors classifier is the estimator. For this model, SVC is the estimator. For this model, what are the parameters? Hyperparameters means C value, kernel value. These are the two hyperparameters. For K nearest neighbors, what are the hyperparameters? N neighbors and P value. For this model, there is no P values available. There is no word of P. P is not available for this one. There is no called as neighbors. There is no keyword called as neighbors. This algorithm is entirely different. That algorithm is entirely different. Right? So just we are going to apply here from sklearn.model selection, import the grid set CV and estimator is equal to SVC. And param grid, the hyperparameters I am going to consider the C and kernel of linear, RBF, sigmoid and poly. Now what happens? Here 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 and 4. 5 into 4. Total 20 models it is going to apply. It will try with the small c value with linear, this value with RBF, this value with sigmoid, this value with poly. Similarly, this value with linear, this value with RBF, this value with sigmoid, this value with poly. In the backend, it is just applying the nested for loop. And it is going to fit for all the different, means 20 algorithms are designed. And out of 20 algorithms, which algorithm is best one means C with 0.01, kernel is equal to linear is the best one. It is not saying that kernel is equal to RBF as the best one because simplified we are going to get in the linear one. No need to go up to the advanced level. For this data set, linear is sufficient. For this data set, the linear is sufficient. And we are going to separate the data. By now, I am going to rebuild once again the SVM model with best hyperparameters. That is kernel is equal to linear. And whatever the C value I have got, C is equal to 0.01. And I am fitting on the data set. And now here also you have got 100, 100. Here also you are getting 100 and 100. Test accuracy, train accuracy. Then what is the difference means? Now if you see the time, whatever the time was taken for this one and time taken for this one, the seconds will be different. Microseconds. It is counting in the terms of microseconds. Is that clear? So for this data set, there is no much impact because easily it is getting classified. Now what you are going to do after the class, once you revise the same thing as it is, and after that, you are going to apply whatever in the last class we have done. That is diabetic data set or one more data set. That is cancer data set. For that cancer data set, now in the cancer data set, these data points are not like this, right? Easily separable, right? In the cancer data set, yesterday's class, whatever we have done in the cancer's data set, the same x1, x2, the two values of x1 and x2, and the hue is equal to output variable, same to same. Yesterday also we have taken the same scatter plot. X is equal to first variable name and this one as the second variable name and hue is equal to output variable name. In today's class also I have taken the same. First variable name, second variable name and output variable name. So yesterday's the scatter plot is like this. Today's scatter plot is like this. So here I am able to separate easily. Now here can you separate easily like that by using any linear line? So here we are going to use with respect to higher dimension. Just apply for this data set and you can see that answers. Now here the linear will not be the best one. In this case, the linear is best one. In this case, we have to apply with a non-linear line. It is going to separate with a non-linear line. That too, the non-linear line is not going to give the 100% accuracy. It will not give the 100% accuracy. Some errors will be there. Okay. So we are going to apply the same concept for this data set. If you apply on the SVM, the hyperparameters will be different. Accuracy also will be different. Means data set to data set, the answers will be different. For my data set, which is the best one, means we have to try all of them. Is that clear? Clear, guys? Once once, for example, this is the data set. Assume this is the data set for which you have applied the logistic regression. You applied the KNN. You applied the SVM. Tomorrow for that same data set, you are going to apply the decision tree, random forest, ADA boost, gradient boost, and XGBoost. Total 8 algorithms you are applying. Okay, 8 algorithms you are applying. Now, for each algorithm, before hyperparameter tuning, after hyperparameter tuning. In KNN also before and after. SVM also before, after. Decision tree before, after. RF before and after. ADA boost before and after. Gradient boost before, after. XGBoost before and after. Now within the KNN, before or after, one will be good, or neither. If both of them are good also, out of that we have to choose only one. If both of them are overfitting problem is there, miss, simply we have to ignore. Sir, before hyperparameter tuning also I am getting overfitting problem, sir. I have done the hyperparameter tuning. After that also I am getting the same overfitting problem. And miss, KNN is not best suited for that particular data set. Simply ignore that one. Next, we are going to move on to the SVM. Like that, once we apply all these things, now using this one, we are going to create the machine learning pipeline. Once the pipeline was designed, that pipeline we are going to keep and we are going to use the deployment. Right? That would be the next stage. Once all the things are completed, using this one, we are going to create the pipeline. Okay. So as of now, just you have to understand simple way. SVM means where it is going to separate the data points on the higher dimension. Based on the some support vectors are considered. Here the support vectors are these data points and these data points are considered as the support vectors. And using the support vectors, it is separating the data points. And which line is selected means maximum margin is the line which is getting selected. Is that clear? That's it. That is with respect to SVM. If you have any questions, you can ask me. So for C value, have to give the same values or different, can be applied. Anything as per your choice. There is no fixed rule that these values only you have to select. Randomly I have taken that values. You can choose as per your choice. Right? Sir, explain once again the hyperparameter tuning. So the same hyperparameter tuning, whatever we have done in the lasso, ridge, elastic net, polynomial regression. But in the polynomial, I have shown you using for loop. But basically, it is also hyperparameter only. In this, all the cases, I have used the grid set CV. And in KNN, I have used the grid set CV. And in SVM also, I am using the same grid set CV. Now, what is meant by grid search CV? Grid search means it is going to search. It is going to search the best value. It is going to identify the best value in the given grid. In the given grid means within the given things, which is the best value. Identifying which is the best value in the given, which gives the maximum CV value. Okay, identify which one is the best one, which gives the maximum CV value within the given values. Grid means within the given. Grid is nothing but whatever the values I have given. So whatever the values I have given, within that, identify which is the best one. So just it is applying the for loop. It is applying the for loop. For each one, it is going to check. For everything, it is going to check. And after that, it will identify which is the best one. Is called as hyperparameter tuning. Right? Sir, is there any mathematical formulas in SVM like logistic regression? We are having the equation. There is no equations like that. Just it is going to take with respect to the higher dimensions. It is going to move to the higher dimensions. Done, guys? Yes. Is there any questions else? Now, sir, here the C value is equal to 0.01. Because this is the starting value, it is selecting. Can you give one more 0? 0.001. Okay, let us try. Still, it is giving this one as the best value. We'll try to increase. So whenever the least value we are getting or whenever we are getting the highest value, we are going to increase or decrease according to that. If it is a decreasing value means we have to decrease. If it is an increasing value means we have to increase. If the 100 is the best value, assume, and higher the value we have to increase. Still, then we have to move on to the next value. If the output variable shows the least value, this one. So in this case, I'm getting this one because in my case, I'm having with respect to easily separable. They are separatable easily. So that is the reason I'm getting in this way. But if you try for this algorithm, you'll not get like this. You'll not get the hyperparameters in this way. The values will be different. So if you try with 0.001, the value will be different. If you try with 0.01, the value will be different. Since in my case, it is getting easily separable. This is the one of the easiest simple data set. Okay, since it is able to classify it is easily, so that is the reason we are getting like that. Is that clear?